Okay, so coming up next is vector line integrals. So you estimated 5 of them today for your homework, and on your homework tonight you will start calculating them. And this is like the beginning of vector calculus, which is a big theme of this course. So they're called vector line integrals, but we usually take them over curves. This is a poor terminology. It should be like vector curve integrals, but it's called vector line integrals. So here's a way I like to think about them. You have a vector field, so here's your vector field F, and I've drawn little representative arrows. The size of the arrow says how strong the vector field is there. Here, it seems like they're all about the same size. Maybe they get a little bigger over here and a little smaller over here. And I'd like to think of them as wind. So I encourage you to think of it as the following way. This is like the field that's outside. The wind is quite strong and it's going in these directions. And all you want to do is just go to lunch. So you have your path, which is like, here's our classroom. And you just want to go to lunch, which is at Sharples, which is over here. And the question is the vector field helping you or hurting you on your journey? So a vector line integral is the integral over your path. So C is the word that's used for a curve, uppercase C, of F, that's the vector field, dot D, vector little s. So ds is like a little amount of distance along your curve, like this, but it's a vector quantity. So it's like a little tangent vector to the curve. So this little vector here that I've drawn, maybe I'll draw it in a different color. So this little thing here is ds. And then your vector field is f. And you're adding up dot products of f dot ds. And we thought about the dot product in 2 different ways in some problems that we did earlier. And a good way of thinking about the dot product is that it measures how much 2 vectors point in the same direction. So if the dot product comes out positive, it means you're going in the same direction. So for here, for example, here's f, and then here's our little vector ds along our curve. Here, f and ds are pointing in very similar directions. So the dot product there is going to be positive. And you can also think about the cosine between them as positive. Here, on the other hand, or maybe here's ds, and here's our f vector. It's basically perpendicular. So the dot product here is 0, or approximately 0. And what this does is it adds up those dot products all along the curve. So here, maybe the dot product is negative. Along here, it's basically 0. And then here, it's positive. And what that means is that as you're walking to lunch, as you go out of the room, the wind is pushing on your side, and it's not helping or hurting you. But then as you get closer and closer to lunch, it becomes a tailwind, and it just pushes you along. So in this case, the vector line integral would be positive. But you can imagine a situation where it would be negative. For instance, if you're done with lunch and you want to come back, you go the opposite direction. If you were to go in the opposite direction, all your little ds vectors would be pointing in the opposite direction, and so all of your dot products would be exactly opposite. And so here, these 2 vectors point in basically opposite directions, so the dot product is negative, and it's adding those up. So in a lot of the problems, first I'll ask you to estimate whether it should be positive, negative, or 0. And so that's like drawing a vector field and thinking about which way your curve is going, and then actually calculate it. And so we'll have situations where it's kind of easy to compute these vectors and life is good, and then a situation where it's harder, but we'll come up with formulas for making it easier for ourselves. That's the plan.